Module 5, Introduction. In Module 3 and 4, we focused on relationships between two quantitative variables, quantitative or numerical variables. In Module 5, we turned our attention to relationships between two categorical variables. Categorical variables like hair color, eye color, blood type, and so on. Categorical variables divide individuals into categories in which order doesn't matter. Examples include sex, ethnicity, and state of birth. Suppose you want to learn whether male or female students are more likely to drink soda on a daily basis. The variables for which students are sex and whether they drink soda or not. Okay, yes or no, and the sex, female or male. Try this. 1. In the research question above, decide which variable is explanatory variable and which one is response variable. So we're looking for explanatory variable or free variable and response variable, dependent variable. List the possible categories for each variable. 2. Imagine that a group of researchers carried out a study of this research question using a website survey. The following table contains the data these researchers collected. The researchers surveyed students about their soda drinking habits and asked the students to identify their sex. Your job is to determine whether there is a relationship between sex and soda consumption habits. So when we're talking about variables and data, remember that we either have numerical data or we have categorical data. When it comes to variables, we have response and explanatory variables. So data are either numerical or categorical. Another name for numerical data is quantitative. Another name for categorical data is qualitative. We're talking about quality. And when we're talking about variables, we either have a response variable or we have explanatory variable. A response, explanatory. Another name for response variable is dependent variable. Another name for explanatory variable, independent variable, free variable. Independent. So when it comes to question 1, what is explanatory variable and what is response variable? So the explanatory variable is sex and the response variable is whether the students drink soda on a daily basis or not. The categories of the explanatory variable are male and female, and the categories of response variable are yes and no. So you have explanatory variable, which is the sex, male or female. The response variable is actually yes or no. Response to either they drink soda on daily basis or not. So we have a nice table. This table has two columns. Drink soda on daily basis, yes, no, yes, no. So these are the answers. And sex, female or male, female or male, and so on. So this is the table that we have. How many answers, how many responses do we get? 1, 2, 3, 4, 6, 8, 10, 12. 12 times 4, if I'm not mistaken, is going to be 48 responses. Very well. Can you tell by looking at the data if there is a relationship between two variables? B, try to summarize these data in a way that will make it easier for you to compare the males and females. One way to display data for two categorical variables is to use two-way table. So how does it work? Look at the data in table 1 above. Look in particular at the number of people in each of the 4 categories. Drink soda daily, doesn't drink soda daily, male and female. So take a look at this table, two-way table. Daily soda consumption, yes, no. So this is your first column. The second column includes female. The third column includes male. So your job as a statistician is to find the number of females who drink soda on daily basis and the number of females that they don't drink soda on daily basis. They're going to do the same thing, the exact same thing for the second category, which is male. Let's go to the board, write down this example. Example of two-way table. So drinking soda on daily basis, yes, no, female, male. So how many female are drinking soda on daily basis? How many they don't drink soda on daily basis? Let's take a look at our table. We need to count all of them. So drinking soda, female and yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It seems like the first block has 12. So how many female do we have that they don't drink soda on daily basis? Let's count them. Here we have 1, 2, 3, 4, 5, 6, 6. Okay. Seems like we have 6 of them. So how many female we expect to get in total? We expect to get 18 female in total. We have to do the exact same calculation for males. So how many males are drinking soda on daily basis? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. 24. And how many they don't drink soda on daily basis? Let's take a look at our table. One, 2, 3, 4, 5, 6, just 6, okay. 6. So 30 males in our collection. So as you can see, we formed and constructed our two-way table, and we have the following information. Write down two ways to calculate the grand total at the bottom right. In this problem, you are going to make up your own values for the two-way table. Fill in the two-way table below in a way that shows that the males and females are equally likely to drink soda on daily basis. So let us move on to question 7. We are interested in whether there is a difference between the frequency of daily soda consumption among males and females. Fill in the two-way table below in a way that shows that the females are more likely to drink soda on a daily basis than the males. So the probability of drinking soda for females must be higher than the probability of males drinking soda. How do we do that? It means that the fraction for female yes must be greater than the fraction for male yes. So I want to take a look at this example that we did before. It's based on the researchers' data that we have. If the question says, what is the probability of a female drinking soda, on daily basis, the calculation is going to be 12 out of 18 of them. 12 out of 18. If you simplify this, you get, so both of these, they have common factor 6. So it's going to be 2 divided by 3. 2/3. If the question says, what is the probability that a male drinks soda on daily basis? Probability that a male that you randomly selected. A drinking soda on a daily basis is going to be 24 out of 30. 24 out of 30. 4/5. So my question for you is that which one is more likely? Which fraction is greater than the other one? Is it 2/3 greater than 4/5? Or is it 2/3 less than 4/5? Which one of them is correct? Or in another word, is 10 greater than 12 or 10 is less than 12? Of course, this is wrong. We all know that. This is wrong. What is correct? This is correct. 2/3 is less than 4/5. So the likelihood of a male drinking soda on a daily basis is higher than the likelihood of a female drinking soda on a daily basis. This is higher. Now let's get back to our question. Question 7 says, fill in the two-way table below in a way that shows that the females are more likely to drink soda on a daily basis. How do we fill out this table? What are some numbers, random numbers you can use that makes the first fraction greater than the second fraction? So think about it this way. You want to have the likelihood of a female drinking soda be greater than the likelihood of a male drinking soda. If you make this size smaller, you get a smaller fraction. So what you can do, you can say that, hey, I want to have just one male. The rest of them not drinking soda. Now, if I create this likelihood, this probability, I get 1 out of 30. Now take a look at this. Here you have 2/3. You have 2/3. And the other fraction is 1 out of 30. 1 out of 30. 2/3 is of course greater than 1 out of 30. 60 is greater than 3. So this is the answer to question 7. You can choose 2, 28, 3, 27, 4, 26, and so on. Just make sure this relation works. The first fraction is greater than the second fraction. Question 8. Now, make up a new set of values showing that males are more likely to drink soda daily. Fill in the two-way table below in a way that shows that the males are more likely to drink soda on a daily basis. We already know the answer. We already created the first table using the researcher's response. For question 8, you can get back, hey, this is just 24, and this is just 6. So we know that the likelihood, the probability of a male drinking soda is 24 out of 30. We simplified this to 4/5, and we already know that 2/3 is less than 4/5. We already have the answer, but you can say that Okay, I want a new set of numbers. You can write, for example, 22, or you can say 26 and 4. We can come up with some new numbers. 26 over 30. Then 13 over 15. Of course, 2/3 is less than 13 over 15. Here, if you multiply these two, you get 30, which is less than 39. You can make changes. You can use 27, 27 and 3. You can use 28 and 2. You can use 29 and 1, and much more. Let's get back to our note. Next step. So one of you asked about the next exam. If you go to our canvas and click on syllabus and then page syllabus and calendar, you have access to syllabus and all the schedule of the exams and the homework are here. Let's get back to our notes. We need to look for even better ways to summarize two variable categorical data. In the next few problems, we're going to use the results from a different survey. The raw data in table 1 above represented the results of a survey of a small sample of students. We need more information. Now we will use data from a hypothetical large sample of students. The more, the better. Here is the information about the larger sample of students. A larger survey about soda consumption was conducted on a website. Visitors to the website were asked to identify their sex. Then they were asked whether they drink soda daily or not. Those who answered yes were also asked whether they drank regular soda or diet soda. So as you can see, we get more categories. Some of the data from the survey are displayed in the two-way table below. Take a look at this. Perfect. Daily soda consumption, sex, male, female, regular diet, soda, diet soda, and no daily soda. So as you can see, you're increasing the number of categories: regular, diet, and no soda, daily soda at all. Question 9 says, think about the way the survey was conducted. Can we apply the survey results to a larger population? Why or why not? Remember that your goal, your job as a statistician is to collect the data, analyze the data, and eventually make inferences about a population. 10, in the survey, which is the explanatory variable and which is the response variable? 11, fill in the missing cells in table 2, this table. And how many people responded to survey in total? Let's go to the board, write down this table here. So we are adding more categories. So yes, no, it was here. So female, male, yes, And yes has two categories, a diet or a regular. Let me just follow the table on the note. Regular diet, so regular comes first. And no at all. Okay, perfect. So let's see, female and male. Now we get 3 rows. And here you have your male first, then female second. So here you have 96. Then you have 36. And the total is also given to you as 167. Then for the female, you have nothing here. How many drink regular soda daily? And you have the diet one, which is 58. And no is 39. And there is no total given to you here, but you know that the total on this side for regular is 168. 168. Okay, perfect. So the sum of male and female who drink regular soda daily is 168. So 168 minus males, the number of males, gives you the total number of females on this block. $72. Thank you very much. Thank you, Cynthia. Excellent. Well done. Now here you have the number of males who drink diet soda daily, and the number of females who drink diet soda daily is 58. The sum is the total, or the answer to this block. Here you get 36 plus 58, which is equal to 94. Perfect. You already know that the number of males who are drinking soda on daily basis is 96 plus 36. You don't have the number of males who don't drink soda on daily basis. But you know the total of them, the total of males who participated in this survey is 167. So if you do a little bit of algebra, 167 minus the sum of these two blocks, 96 plus 36, you get the number of males who don't drink soda on daily basis. So 167 minus 132, which gives you 35. 35 of them. Thank you very much. Excellent, everyone. Thank you. And finally, how do you find the total here? The total is 35 plus 39. 35 plus 39, which gives you 74. So the question is asking that what is the total number of people who participated in survey? Well, we know the number of males who participated in the survey. We can find the total number of females who participated in the survey. If you add these together, the sum of these two is 130 and 169. If you add these together, must be equal to the sum of these numbers on the first column as well. So the sum of the last row numbers and the sum of the first column must be the same. We can check to see if that's true or not. I don't like my table, just a little bit contorted. So if you add these together, you get 336. If you add these together, it must be equal to 336. This is the total number of people who actually participated in your survey. So the sum of these two is 168, and 168, it gives you 336. Excellent, perfect. Total number of people who participated. What's next? 13. How many female respondents in the survey drink diet soda daily? What percent of female respondents drink diet soda daily? What percent of male respondents drink diet soda daily? And is the percent of survey respondents who drink diet soda daily higher among female or among males? So question 13 says, how many females actually drink diet soda daily? This is question 13. Okay, diet soda daily, 58 of them. 58 females drink diet soda daily. Question 14 says, what percent of females drink diet soda daily? What is the percent? Percent of female who drink diet soda daily. We don't calculate this out of the total male and female. Our focus is just on female category. So it's going to be 58 out of 169. So if we just do the calculation, it's yes, perfect, perfect. 34.3%. 34.3% is the percentage of females who drinks diet soda daily. Question 15. Question 15 says, what percent of males drink diet soda daily? Now we look at our focus is on the category including males. Diet 36 out of 167. Okay, let's find the percentage. Very good, nice, excellent. Thank you, everyone. 21.5, 21.6, 21.6% is the percentage of males who drinks diet soda daily. So which percentage is higher? Is higher among women, among females, or among males? Which one? As you can see, yes, excellent, thank you. As you can see, the percentage for females is larger than the percentage for males. So the answer is for females. Since 34.3% is greater than 21.6%. Because percentages are more helpful in comparing the data, the result, we often change the frequencies in a two-way table into percentages because it's much more helpful. In this case, because sex is the explanatory variable, we calculate the percentages within each sex group. because the explanatory variable is the column variable, we only look at the column totals. Then we can ignore the totals for each row. So we're interested in columns and the percentages. Calculate and insert the missing percentages in the table above. You need to calculate the percentage of males who drink regular soda daily and who don't drink regular soda. And question 18 says, are the column totals exactly 100%? If not, why? What's the reason behind it? Okay, let's get back to the board. So now we have to do a little bit of division. 96 divided by 167, because we want to find the percentages. 36 divided by 167, and 35 divided by 167. We're using approximation. So instead of using equality sign, we use approximation sign, approximately. And here for males, we do the same. And we're going to ignore this. Just want to keep the total here to remember that we have 336 participants. So here you have 72 divided by 169. 58 divided by 169. And 39 divided by 169. Again, let's use approximation. Okay. So we already calculated two of them for diet soda daily. For females, it's approximately 34.3%. For males that we calculate was 21.6%. What are these percentages here? Oh, it's reversed, I'm right, yes. This is 21.6, thank you. And 34.3. So 96 divided by 167 gives you 57, thank you so much, 0.4%. And 35 divided by 169 gives you 21%, excellent. Thank you very much. And then 72 divided by 169 gives you 42.6%. And 39 divided by 169 is approximately 20. I'm waiting on you. 20%, okay, perfect, approximately 20%. Okay, if we add these together, it's not going to be exactly 100%. Not exactly 100%. Not exactly 100%. Why is that? Because we don't have the exact value. We just used approximation, so it's not going to add up to 100%.